Okay, so let me do an example of vector addition by using vector decomposition. Alright, so first let me draw an XY coordinate, and I'll do exactly like what I told you before, two vectors in this first quadrant, XY axis, and my first vector is vector A. The angle it's making with the x-axis is 30 degrees, and vector B is a little bit shorter, and the angle that is making with the x-axis is 60 degrees. So obviously the resultant vector will go somewhere in between. I'm not going to draw it yet. Now let me give magnitude to these vectors A and B. Let's say the magnitude of A is just 10 in some arbitrary units, because I'm not talking about anything but in particular just vectors. And vector B, the magnitude of vector B is just 5. So to make things simple. And there's also a reason that I use these numbers, because it's you will see in a second. Now what I want to know is I want to know the resultant vector C, which will be vector A plus vector B. I want to know vector C, magnitude of vector C, which we call C. How much is that? And we also want to know the angle that it makes with the x-axis. Alright? So we want to know direction of C also. So as I said before, now A can be decomposed into AX and AY. AX will be in the positive X direction, AY will be in the positive Y direction. Why is that? Because it's in the first quadrant and is pointing in that direction, so obviously the X component will be in the positive X and Y component will be in the positive Y direction. Similarly for vector B, if they are in other quadrants, then it will be different. So that will be in another example. So here AX, the magnitude of vector AX will be magnitude of A times cosine 30 degrees. Why cosine? Every time you want a component that is adjacent to the vector, you see, on the side of the angle will be cosine. And if it is on the other side or the opposite to the angle will be sine. Okay, so here A is 10, cosine 30 is 0.866. How do I know? I just happen to know this number. And so the answer is 8.66. All right, 10 times that. Similarly, I can find AY. AY will be A times sine 60 degrees. Sorry, sine 30 degrees. And I know A is 10 and sine 30 is 0.5. That's why it's easy. So AY is just 10 times 0.5 is 5. Similarly, I can work out on B. So BX will be just B cosine. This time the angle is 60. B cosine 60. This component B cosine 60. And cosine 60 is again 0.5. B is 5. Cosine 60 is 0.5. So that's just 2.5. Alright. And what about BY? BY is again B sine 60 degrees. So now B is 5. Sine 60 is, as I said before, 0.866. So sine 60 and cos 30, they are the same. Sine 30 and cos 60, they are the same. All right. So these things, like if you know, it helps. So now 0.866 times 5. So then I you can multiply it out actually, but I'll just use the calculator. So 0.866 times 5 will be 4.33, right? Actually, I can just tell from here that'll be 4.33. Right? I mean 0.86 times 5. So now I get both AX and BX and AY and BY. So now if you look at that in the vector decomposition way, look at this. AX is 8.66, so it's about this J big. So that's AX. And BX is AX is 8.66, BX is 2.5, so a little bit shorter. That's BX. They are in the same direction, they will add up. And similarly, AY, which is 5, and BY is 4.33. So AY is 5 and BY is this much. So this AX and BX will add up and it will give you a longer vector in the X direction, and let's call that RX. Right? And then AY and BY will add up, and then I'll get something called RY. So now RX and RY add up, and then I'll get the resultant vector by using this parallelogram law. But since they are perpendicular, it's very easy. That'll be my final resultant vector R. All right? So let me find Rx, which will be AX plus BX, because they are in the same direction, so I don't have to do anything fancy. That's why it's useful. AX is 8.66 and BX is 2.5. Right? So AX and BX, you add them up and you get 11.16. All right? 8 plus 2 is 10, and 6.6.5 is so 1, and then 1.16. So that's what you get. And then let's see, what about RY? RY is AY plus BY, and AY is 5, and BY is 4.33. So together you get 9.33. So the magnitude of R is obviously Rx squared plus Ry squared, and then you take the square root, because that's from Pythagorean theorem. Rx squared plus Ry squared will give you R squared. So magnitude of R is square root of Rx squared plus Ry squared. And Rx and Ry, let me put the values, 11.16 the whole square plus 9.33 the whole squared. Take the square root, and then you get, let me see. So if I work it out on the calculator, what I get is 14.546. So you can check it out. Sometimes I type in stuff wrong, and so you can check it by yourself. That's even better. And the angle between the R vector and the x-axis, let's call it theta, will be tangent inverse of Ry by Rx, which is equal to tangent inverse of Ry, which is equal to 9.33 divided by x component is 11.16. Then I take, let me use the calculator, and the answer is 39 0.9 degrees. Okay, and so that's how you find the resultant vector by using vector decomposition. All right, so I'll see you in next video.